Does anyone have any experience with Elm at all in the room? No. So there were a few people that have done some React, obviously. So there were like 4 of you or so. So you have. Didn't you say you've been playing just a tiny bit? You've obviously done some. You have not yet, probably. Okay, sweet. Jared?
Not really. A little
Sweet. Yeah. Actually, I have some introduction before we get there, but good to know kind of where y'all are coming from. So this is Ybor. This is functional Ybor put on by Ybor Tech. Ybor Tech exists to grow, encourage, and support the tech community in Ybor City. Maybe create it if it doesn't exist. I mainly do this because I don't want to have to someday be forced to drive across the bridge someday. So my hope is that companies will exist here so I can ride my bike there if I ever not employed where I am now. So future meetups are there and you're all there. There's also a Slack room, which I have been pretty diligent in posting in. It can be kind of quiet sometimes, and we're on Twitter, Instagram. Hi, I'm Tony Winn. I've been working on a side project called Get Traction. You can check that out. It's analytics for solo founders. And I'm learning a lot about how difficult actually getting traction is. So I'm Tony _ Winn on Twitter, T-Winn on GitHub. So introduction to Elm. What is Elm? So it's a functional programming language, and so when we talk about functional programming languages, you can write functional code in pretty much any programming language that you'd like to. How functional a language is considered is generally based on like how strict is it going to be, what is it going to allow you to do, how much mutable state will it allow, does it have ways, like in Ruby, you can mutate pretty much anything, but you do have the option of freezing something, so you can kind of opt into immutability. So Elm is a very functional, more purely functional programming language, which means that it's going to be, you're going to have to be very intentional with managing the side effects of any kind of interaction. So it is also a statically typed language. So that means everything has a type. It's not duck type like you would in Ruby, where it can kind of take anything. You have to be very specific with what the inputs and outputs to your function are as far as types. And it targets the browser, so it only compiles to JavaScript. You don't have the ability to run the server side. You don't have the ability to run this native. Maybe at some point it'll add other targets, but right now it is just looking at targeting the browser. So it started out as a comp sci thesis for Evan, and I don't know how to spell his last name, but he went to Harvard. He released it a year before React was released. So it's not brand new, but it is kind of more recently you're hearing more and more about it. So it is inspired enough other things that I think people are starting to get back to it. So I wanted to take a little bit of time just to give you basic syntax of Elm. Sit. So, and this is my slides, and this is okay. We don't really need to see the test, I guess. So this is basic a hello world in Elm. So here you define a module, and then you define what it is that it exposes. So this is saying expose any method that's in here. We could change this because our method name is hello world. We could say hello world here, like that, and that would also work for us. This is our type declaration. So it's saying we've got a function named hello world. It inputs a maybe, which is going to be it inputs a maybe, which has a type of string, and it outputs a string as well. So this is actually defining the function. So the name of the function is this, and the name of the input that's coming in, name here, is that, and you just basically this is an example of a case statement. So it is a strongly typed language, and so let's play around a little bit. So the compiler is going to kind of be your friend as you go through. Like so a maybe here is a kind of composite type. So there isn't nil in Elm. You get this nothing thing, and when something could be nil or nothing, you've got to give it a type that will support the nothing type. So the maybe will either return just a value or it'll return nothing. So let's say we only handled the type where maybe was just a value. If we run this, the compiler actually tells you this case does not have branches for all possibilities. You need to account for the following values, maybe nothing. Which is maybe feels a little bit heavy-handed based on what your language, what language you're coming from. But the cool thing that this allows is that Elm has a promise that you will get 0 runtime errors. Like, it is a mathematical promise. If your application will compile, you will not hit a runtime error because the compiler has checked every possibility of all your inputs and outputs, which is pretty sweet.
Especially if you get airbreak notifications.
You won't anymore. You'll just never be able to compile your code. You'll never make it past that. So I said it was statically typed, and it's obviously strongly typed. But it's also, we can actually, the type definitions are optional. And it completely works fine without them. Let me jump back into our tests here. I haven't actually tried this previously, so this is, I'm sure, gonna be an interesting failure. But like, what happens if we pass 4 into this hello world? What will it try and tell you? First argument to function test is causing a mismatch. Function test is expecting the first argument to be a string, but it's a number. So super, super helpful feedback inside of the compiler about what it's expecting and what the actual problem was.
And it's inferred that that's supposed to be a string because you use string operations on it in the just value fork. Is that?
Yeah, I mean, here I'm stating it explicitly,
right.
But it can infer it.
Right, when you,
So if
you
you
get that
remove
error
the-
if you don't have, if you,
Yeah, what? Oh, sorry.
Right, yeah, so when we just ran it, I did not have the type definition,
Right,
so it was
okay.
able to infer it.
Okay.
Yeah. Exactly. Questions so far? Cool. Let's jump back over. So features that we just saw, so it is typing that's not just static, but it's strong and it's inferred typing, which basically has created the most helpful compiler that I've ever worked with. And we get the guarantee that there are no runtime exceptions. And the documentation says the only way to actually do it is by explicitly calling crash, which is a function of their API. So other cool features, it being a, so the compiler to it is actually written in Haskell, which is the first project that I've heard of like successfully doing something in Haskell. I've never heard of a practical Haskell thing, but the Elm compiler does it. So it has a lot of these kind of patterns that I think have been kind of inspired through the Haskell world and certainly the functional world in general. But this case you can kind of see, and you could maybe see it in the last one, but we've got this case that's going on here, and it's if the thing coming in is an empty array, it matches on that, and it says that there aren't any words. Apparently it takes in like a words array. Yeah, this is your array of words. So it'll actually never hit this since that's hard-coded, but imagine if that was something you brought in. But you can also decomposite, or destructure, I guess, the array using this dot notation. So that'll take hello and bind it to the head variable. So this will just say hello on the screen. not get any word. And then tail will be an array with just word exclamation point. So cool, partial application with auto-currying on everything that exists, which is awesome. You just get that by default. Aaron kind of talked about that last time. But basically, yeah, it's data last operators on everything. So in this particular example, like this is how you assign something. So you've got to do it within a let context, and then you say where that gets applied to. So this is an anonymous function that I am passing to map, which is just going to take whatever it gets. It's a string, I guess, and add question mark, question mark, question mark to it. So it's going to go through this, and it should, what it'll actually return when it goes through is like hello, question mark, question mark, question mark, if there's text. Partial application with auto-currying, I know that is like, that's a lot of buzzwords put together, and if you weren't here last month, I don't know, Aaron, do you want to pipe in and explain?
So essentially, if you have a function that takes like 3 arguments or something like that, partial application and currying would basically allow you to provide those arguments at different points in time. So you can take that function and give it the first argument, but say you didn't have the other pieces yet. You could then pass that function around and then give the other ones, and then once you gave them all, it would give you back a value. You could also even, well, yeah.
Are you actually using that here?
I am. So map is a method that takes 2 arguments. So the first one is the function,
okay.
and so the second one is the actual data. So
Yeah, so
here's
he's
this
applying it
question,
down there.
I apply it right here.
Okay. Makes sense. What, is there any significance to the underscore back there, or is that just we don't care about this, so I threw it away?
Yep, exactly.
Okay.
Other questions?
So Facebook, Haskell, talking about Haskell, they just have like a big, they just redid like a lot of their like spam and like detection stuff like that, and it's all like policy driven and blah 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 blah. And I think it's using Haskell.
Sweet.
It's kind of crazy.
So this was obviously a super basic introduction to Elm the language, but it's not just a language, it is also a framework, or at least people talk about it this way. And when we're talking about the framework, we're talking about Elm architecture. So in much the same way, like in Ruby, you've got Ruby and you've got Rails. In Elm, you've got Elm and the Elm architecture, and you as far as I know anyway, you write Elm apps in the Elm architecture, and there's not like option number 2. Like you're opted into the Elm architecture. But thankfully, the Elm architecture is a super powerful pattern. So basically, the Elm architecture is composed of 3 different things. It's got a model, which makes sense. It has a view, and then does anyone have a guess on the 3rd thing?
Whatever.
Something that's not a controller. It's update. So it is the pattern. So you've got your model, which represents by some sort of business logic, or the representation of some kind of entity. And then you've got your view, which maps a model to an expression of a UI that exists. In very much the same way of React, where it's data in, data out. If you have this particular model that's being exercised, then every single time you're going to get this same representation of the view. And then the update is basically, like, if you're familiar with Redux, it is your reducer pattern. So let's run through a really simple example. It is an example of a counter. It is not a counter.
How not to do this?
So in this particular one, you need to define what your model is, and in this one, we're just saying our model is an integer. So in a application where you're just representing a counter, an integer works well enough for what you're trying to model. And this is a representation of an Elm view, which at least in my mind reminds me a lot of what you'd be doing in ClojureScript. Does this look really similar to ClojureScript's
Actually, yeah.
DOM
Kinda, yeah.
representation?
Yeah.
So you don't need to understand this a ton, but basically these different HTML elements, the first kind of array here is the attributes of it, and the second one is like the content inside. So we basically, to translate this normal HTML, we have a div with no attributes, we have a button with an on-click event, which takes in an address and a decrement, and then inside of that button, the content of it is a minus. And then we have a div that has a style, but we actually can't see, it's not defined here. But basically, we display some text to there, which is taking our model and calling toString to it. So we've got our integer, like let's turn it into a string. And then a button for the increment, which is exactly like the decrement thing. Make sense?
What's the first line mean?
This line right here?
Yeah, I followed the HTML bit, not this
Yep,
part.
so that is your type definition. So all of this is just pure functions. So again, this is something that you could leave off. There is, so this is a complicated, or beyond my level of knowledge, but basically how these things actually hook up together are through a series of signals with these messages that, it's basically saying, like, given a signal and an action, and a model, I'm going to output HTML. So this address is the type signal address. I don't know why action is there, actually. I'm not totally sure on that.
That's-
and then the model is the model.
I mean, it looks like that should be the sort of subtype thing, like the maybes earlier.
Yeah.
Oh,
The
so
signal
it's
address
action-
is
An
an
action.
action.
Yeah.
That makes sense. And then this is our update function. So our action, just like our maybe was like just or nothing, basically. Our action is either an increment or decrement. So our update basically takes in an action and a model, and it's going to output the new model from it. So
Yeah.
this is obviously super easy. We can match on the type of our action. So if it's increment, we're going to do a +1 on our model. If we do decrement, we
Sure.
do -1.
Are increment and decrement built-in concepts, or do they just exist because we defined them?
Just exists because
Okay.
of this line right here. Any other questions, comments? And then there's a little bit of boilerplate. So this, like, this exposing start basically takes care of all the signal, like, routing kind of stuff for you. So given a simple project, you can get started using this and not have to kind of know all about under the covers how things are getting tied together. But you basically start the thing up with a model with a default state. This is like JavaScript object notation in Elm. So instead of doing colons, you do equals, but it's they call them records in Elm. Yeah. Questions?
Can the keys be anything?
Can the keys be anything? I don't believe so, at least for the start, that it is looking to have those three things.
Oh, sorry, I meant like any type, because like JavaScript objects, like the keys are strings.
I don't believe so.
Right.
Because I don't even know exactly what the type is of the keys here.
Mm-hmm.
So Elm architecture we just went over. So here's a quote somebody said about it. Even if you don't plan to use Elm, you should read about the Elm architecture.
Somebody.
I'm about to tell you. We should look there for inspiration. And so this was Dan Abernov, who's the Redux author, which is, he's obviously has a lot of praise for Elm, and a lot of the ideas kind of in the React community there's a lot of like cross-pollination with what's going on in Elm. So if you want to be better at Redux, learn some Elm. So wrapping up, who's it good for? React Redux fans who want to go all in on functional programming. So you'll recognize a lot of the patterns from that world, but you will maybe not be able to hang yourself as easily with mutable state. So this obviously has lots of constraints. Elm is a language of constraints. Functional programmers who want to do work on the web, and anyone. Elm has invested a lot of time in its compiler for it to be friendly, a lot of time in its docs, and the creator of the language has basically said, we want this to be mainstream. We're not looking to be like some kind of subset. We want this to be as beginner friendly as possible and be able to take you to however complicated your app wants to be. So they are at least striving to be a very beginner friendly community. So wrapping off, what are the trade-offs? JavaScript interrupt. I think that they have probably improved this story a little bit since the last time I tried to do it and failed at it, and I probably know more. But it's not completely straightforward, right? Like you're in a functional programming language that's very pure. They're not going to let you go out and just make calls willy-nilly into JavaScript without any kind of safety inside of that. So there are ways to do it, but it's not going to be as straightforward as if you were in React and wanted to just call some other library. So JSX versus Lispy DOM representation, you guys saw that. JSX looks really nice. There are some gotchas, obviously, that you have to know when working with JSX, but some people might prefer JSX to this DOM representation. It's probably harder to find devs that actually know it. I don't know anybody that knows it. And like, if you work for a company, that's a real thing you gotta think about. So wrapping up, where to start? Elmlang.org.examples. I was playing with this before we got here. So there is, I'll actually go back. Examples. Yeah, so there's like a ton of different examples here. So a lot of different problems that you might have that you're trying to solve. You can go in and find an example that's kind of hitting something similarly. But the Mario one's really pretty cool. And I didn't really talk about it, so this is all written in Elm, 144 lines to get this here. It is like very much like Redux. You've got the time traveling debugger, like that's kind of built into the framework. I wanted to real quick show. So I think this is gravity. So if I change this to 1, hot swap, yeah, you can't jump very high. If I do it to 100 and then hot swap, but then I can also hot swap back with a high gravity. So yeah, it's a super powerful language because it's purely functional. You kind of can do all these things kind of on the fly, which is awesome. So there are lots of great examples here. Definitely recommend going through and playing with those. I've become a really big fan of exorcism.io. Anytime there's a new language that I want to play with, going through their examples has been super helpful to me. Like I like learning in that style. Has anybody used Exorcism? Familiar?
Yeah, but like what's like what is it?
Yeah, so it basically is a series of coding challenges that you can go through, and there's like a plan that you can go through, and then you submit your solution to their site, and you get feedback from different people on the site around your code and what you could have done. So yeah, that's it. That's questions?
How do you find Elm like with Ruby?
How do
In
you-
the sense of the syntax and things like that, like
It is.
you said it's a pure language, right? So
It's more purely functional. So like, for example, I had wanted to like assign a variable, right? And I'm used to being able to just saying like a name of something is equal to the name of something else. But like in Elm, in order to do that, in order to assign questioner to something, I had to do it with inside of a let context. So there are definitely like rules like that that you've just kind of got to know, and it can be a little frustrating getting started because you'll just bump up against like rule after rule of what you're not doing right. But honestly, there's not that much to learn as you're going through. But Ruby will let you like do whatever you want, right? Like for better or for worse. So it's definitely a trade-off. Like you have strong guarantees of safety within Elm once you've compiled, and Ruby you can't have that.
So this style, compared to how you do it in Ruby, this is a little bit like I'm going to open a handle to a file, but I'm going to use the block style instead of.
Right.
You know what I'm talking
Right,
about?
yeah.
So this is a little bit like opening a file with a block.
Oh, okay.
You only get it during this chunk, and then it's gone.
And then it's gone after?
Yeah.
That makes sense.
And just like opening a file with a block, that gets you some benefits. Now I don't have to worry about closing this thing.
Right.
In this case, now I don't have to worry about my state. It's just
There.
Or memory or.
This is very, very similar to closure too. So for instance, closure being a list, you have to define everything in these list structures. And so in order to define variable bindings, you use these let clauses. And they make them convenient. You can do them as part of your parameters. There's lots of really fancy destructuring you can do and some really tricky, cool stuff. But like at first it was like super annoying to like have to define like, oh damn, now I want to hoist a variable up, and now I have to go like, put in this let thing and like figure out where the hell the other parenthesis goes, and then like, and but after you kind of get it, like the kind of freedom it buys you of knowing like, okay, this thing is only available here inside of this like kind of closed little area. It helps you be able to like think about like, where is this state going? Where is it getting leaked out somewhere else? And that's really handy. That's really nice.
Yeah.
I have two. So I think I read in the summary that it compiles down to JavaScript.
Yep.
What does it look like? I kind of want to see what the JavaScript looks like.
It's going to be machine JavaScript for
yeah.
sure. Probably.
It's you can unuglify something in Chrome now.
This is true.
this is just the
Probably go to
DOM.
sources
So-
and hit scripts.
Well, so when you run the
Hey, output.
Elm like command line tool, it like compiles into like a main.js, and that's like your application, right?
Right, a pattern.
Okay.
For that, yeah. So deploying it is just like deploying any other static JavaScript or whatever at that point.
It looks so cool, but they've like right now, I'm doing something in React and Redux, and I've got to build a component, and I am building a component to wrap this ancient 3D rendering gizmo that has this abomination of an API, and you can only actually you can script it, but you have to like actually write this its own little pseudo scripting language that you then inject into it by XML and all this junk. But that's a pain already in React. It sounds like that would be much more painful to. We didn't really see what it looks like when you're trying to talk to imperative JavaScript.
Right.
So
yeah.
that'd be the.
It is not going to make that case easier for you than for sure.
So just to check, this is for like client-side web apps, and it's just plain like simple JavaScript at the end of the day.
JavaScript, yeah.
Okay.
Yep. So if you remember in our start deal.
What does that look like in JavaScript?
Even like the hello world appears.
I watched a talk that showed what the output was, and I don't know, like minified JavaScript is minified JavaScript. So I thought, yeah, this doesn't actually show it. So you can bind it to a particular div for it to render in, or I think this particular one is gonna take up kind of the entire screen. Anything else? Good. Sweet. All right, thank you.
Thanks, sir.